So let's continue, dear students. Now comes the other question, and you have been given this: x squared plus 4y squared minus 4x minus 24y plus 24 equals 0. You can refer the question back, please, if you want. So this basically is equivalent to x squared minus 4x plus 4y squared minus 24y equals minus 24. Is just simply rearrange the terms here. And then x squared minus 4x plus 4, you see 4 into y squared minus 6y plus 9 equals negative 4 plus 4 plus 36. I just have written this in such a way that I can have a certain standard equation of the conic section. You see, I can have such approach. What I did here is, look, x squared is directly written as it is, minus 4x is here. So here, half of minus 4 is 2, and squaring that makes 4. I have added 4 here, so the same has to be added here, 4 to the right side in order to keep equivalency. Here you can take 4 as a common out, then y squared minus 6y can come. So as can be shown here, half of minus 6 is basically minus 3, and squaring that it will be 9, so you can have 9 here. I'm writing this expression here because I just need to have a square of a certain binomial, and this is done in order to have a standard equation of a conic section. So what you added here must be written to the right too. For instance, as I told you earlier, 4 was added, so 4 is written as it is. Now here, what is added here? 9 is written, so 4 times 9 is 36, so 36 is going to come as it is, as you see. And here you have these expressions. So this is going to be x minus 2 the whole squared plus 4 into, you see, y minus 3 the whole squared is equal to 16. This can come. So look, 4 can be cancelled by 4. Minus 24 plus 36 is going to be, look, 4 can be cancelled by, minus 24 plus 4 is minus 20. And minus 20 plus 36 is 16. So I am having here x minus 2 the whole squared plus 4 into y minus 3 the whole squared is equal to 16. I'm having this. So what is this? This is nothing but it is the equation of an ellipse. Dividing the whole by 16, I can have this to be x minus 2 the whole squared divided by 4 squared plus, you see, y minus 3 the whole square divided by, again, 4 is equal to 1, but I can write 4 as 2 squared. So this is an ellipse having center 2, 3, because at x2 and y3 everything goes to what? 0. Because of this, the center of the ellipse is at 2, 3. So the semi-major axis length is a, and that is, look here, it is 4, and the semi-minor axis is going to be 2. The vertices of the ellipse are, you see, 2 plus 4, 3, comma 3, because I'm adding here 4 because it is the major axis is parallel to the x-axis, so we have to operate this number 4 on 2, and 2 plus 4 makes 6, so 6 is 3 is the vertex of the ellipse. One of the vertex of the 4 ellipse is going to be this one, and 2 minus 4 3 minus 2 3, because we are deducting 4 from 2 again from the center in order to know the left vertex. 2 minus 4 3 minus 2 3, which in turn are vertices of the hyperbola. So the vertex are going to be the vertex of the hyperbola, because you see the vertex of the ellipse are taken to be the vertex of the hyperbola. Okay, so now the center of the hyperbola is obtained. The center of the hyperbola is obtained to be at 2, 3, center of the ellipse. So from this, transverse axis length is given by 2a, which actually is 6 minus minus 2, which basically is 8. So half of 8 is 4. So a is 4. Thus, the equation of the hyperbola is going to be determined by using x minus 2 the whole squared divided by 16 minus y minus 3 the whole squared over b squared equals 1. You see? Now from this, we can determine what the value of b is. Basically, the value of x can be substituted, because it is a point 2 plus radical 32, and 6 is lying on the hyperbola, and because of this saying, 2 plus radical 32 can be placed in x and 6 can be placed in y. So based on this, you can determine what b is, and from this, the value of b is obtained to be 3. So b is obtained to be 3. Now the equation is going to be x minus 2 the whole squared over 16 minus y minus 3 the whole squared over 9 is equal to 1. This is the equation of the hyperbola. We are asked to determine the equation of the hyperbola. So it will be like this. And how can we determine c? C is easily obtained by taking the square root of the sum of the square of the two, which actually is a square and b square. So it will be a is already obtained, it is 4, so 4 squared plus b is 3, so 3 squared. So this is 16 plus 9, which actually is 25, and radical 25 makes 5. So the value of c is now determined, it is 5. So the focal points are the focal points of the hyperbola are, you see, obtained to be minus 3, 3 and 7, 3, because we are having here 2 minus 5, comma 3, and also 2 plus 5, comma 3. We are simply adding 5 on 2, 3, and subtracting 5 again onto 3, and this makes to have 2 minus 5 comma 3, which actually is minus 3 comma 3, and 2 plus 5 comma 3, which actually is 7 3. Okay, so we have these results. Okay, so this is the one that you need to know. Next we have to determine the asymptotes of the hyperbola. The asymptotes of the hyperbola can easily be determined. How is that determined? Using the formula y minus k equals plus or minus b over a into x minus h, we can determine the asymptotes of the hyperbola. We knew h and k, they are already obtained to be 2 and 3, so have them as they are. And we knew also b and a, you see, they are 3 and 4, so label them as they are. So finally the asymptotes can be determined by using the equation y minus 3 is equal to plus or minus 3 over 4 into x minus 2. So this further simplified as y is equal to, you can take this minus 3 to the right side, okay, and it turns to be plus 3. So this is going to be a plus or minus 3 over 4x minus 2 plus 3. So after simplifying this, the asymptotes are going to be y is equal to 3 over 4x plus 3 over 2, and y equals minus 3 over 4x plus 9 over 2. So we can also write this in terms of standard form, as you see, just a matter of multiplying this by their least common multiple. 4 and 2, we do have 4, so let's multiply the whole by 4 and rearrange everything in such a way that we can have standard form of equation of a line. So for this we have this one, and for you see the second one we have also this. So the two asymptotes of the hyperbola are these two. This is all about the question number 4. Now what comes next is question number 5. In question number 5, you see the points 0, 0, 10, 25, 40, 40 lie on the parabola. We are given with these 3 points lying on the parabola. Okay, please try to read the given question there in the previous slides. Okay, you need to understand the question first. A hyperbola is given, a certain bridge is given. So on the parabola of this on the bridge, the parabola is designed, you see, the bridge is designed in a parabola form. So the points 0, 0, 10, 25, 40, 40 are, you see, lying on the parabola. So having this into account, you see, we are going to determine the equation of the parabola. Okay, the equation is already given to you. So in place of x and y, we are supposed to substitute 0 in place of x, and again 0 in place of y, because the parabola is assumed to pass through this point 0, 0, the origin. So this is 0, and here again it is 0. We just have replaced in place of y and in place of x these two zeros. Then everything is as it is, because the equation is already given to you. So b square over 4a square can come from this square, and here also b square over 4a square can come again. Here minus c over a, because 1 over a multiples c, minus c over a can come. These two can cancel each other. Then c over a equals 0 follows. From this c equals 0 is going to be obtained. So later when we write the equation of the parabola, we will never have this c, because it's obtained to be 0 from, you see, this one. If the parabola must pass through the origin, or if the origin lies on the parabola, must you have c to be 0. Okay, next we have also given that the point 10, 25 lies on the parabola. So in place of x again you need to use 10, and in place of y again you need to use 25. So put these values, x is here and y is here. I just played that, and next task is a matter of simplifying this. Look, students, after simplifying this one, what you need to do is you have to multiply this twice and equate this with this one and try to rearrange everything in such a way that you see we can cancel one over the other, and by collecting like terms together, and finally you will come across with this expression 20a plus 2b equals 5. So have this as equation number 1, and we are also given that this point, you see the point 40 40 lies on the parabola. So again, in place of x and y we are supposed to substitute this 40 40. Dear students, I just simply have copied this one and pasted here, but please have a correction. In place of 10 use 40 again. In place of 25 please use 40 again. But after simplifying all this you will finally obtain b to be 1 minus 40a. So look, students, using equation number 1 and equation number 2, combining them, we can determine the values of a and b. So combining 1 and 2, look, 20a plus 2b equals 5. And look, in place of b, now in place of b here you can put 1 minus 40a. 20a comes as it is, but here 2 is taken as it is. But in place of b, look, 1 minus 40a is used, and this has to be equated with 5. Look, and this is going to be what? 20a minus 80a, and this is 2 times 1, and after rearranging this you will obtain a to be negative 1 over 20. Once you obtain a as like this, you see it is so simple to determine what b is, because b is 1 minus 40a, so simply substitute negative 1 over 20 in place of a, and this basically is 3, because you see this 40 times 1 over 20 is 2, and you have minus minus being plus, so 1 plus 2 can come, so the value of b is 3. So everything is now known, guys. A is known, b is known, c is known. So the equation of, you see, the hyperbola, I mean the parabola, can easily be determined by using this one. Look, this is the equation of the parabola according to the way it is given. Okay, so this, after simplifying it, you can also obtain this expression. Okay, this is the equation of the parabola. Now what comes next is, you see, the focal length, determining the focal length of the parabola. For the focal length, you see, we have 4 times b equals 20. The focal length simply can be obtained simply just dividing this by 4. So this is 5. The focal length of the parabola is 5. And in the third question, you are asked to determine whether you see a certain vehicle of a certain height can pass through that's tunnel, the tunnel that is made according to the ellipse form. So let's check that one. Ignoring the other possible factors, the maximum height of the parabola is at its vertex. So the vertex can easily be calculated from the equation x minus 30 the whole squared negative 20 into y minus 45. Clearly the vertex is at 30 and 45, because the zero of this expression is 30 and the zero of this one is 45. So the vertex of the parabola is 30 45. The parabola is opening downward, as you see. It is, you see, having a negative sign. So the vertex is at 30 45. But the lorry, you see, just read the problem please. The lorry has been said that it has a height of 42.25 feet. You see, and the lorry has a height of 42.25, and clearly this cannot pass, so because 45.25, you see, is greater than 45. Since 45.25 is greater than 45, you see, it has been said that, just have a correction here please, this is 45.25. It has been said there 45.25. So if the lorry is having a height of 45.25, it is greater than 45. If it is greater than 45, oh dear, you see, the lorry can pass through the tunnel. It can't pass. So this asserts that, you see, the lorry can't pass through the given bridge. I hope you have understood the question. Thank you very much.